The topic today that I want to cover is data residency, high availability, and disaster recovery with your Gen AI apps. This is a conversation that I think goes to what Ron was talking about, being able to not just execute on the Gen AI side, but how do you build a large scale application? How do you do that cost effectively? How do you keep it up and running and disasters and those kind of things? So we'll get into that. But just a quick intro, Chris Wiederspan, as I said, I'm an Azure App Innovation Specialist at Microsoft. Been there for about 7.5 years. My background is in software development. My day job, I usually describe as helping customers build and run their apps in the cloud. I work with large ISV customers that work or use Azure, partner with Microsoft. So a lot of this information that I have here is from the field, right? I mean, this is information that I've gathered from working with customers, public information, all that. I say that because I want to be clear, like I'm not here as a authorized person to talk about things like Microsoft capacity, Azure capacity, and all that. I have very little insight into the internal workings of how Azure does capacity management and all those kind of things. But I will speak about the practical side of it. What do we go through with our customers and how do we help them architect their capacity needs, their HA, their DR, all that kind of stuff. Just real quick, high level, level setting. We'll talk a little bit about some kind of just important baseline information, data residency. That's a big part of Gen AI, especially when you're trying to figure out how to architect a large scale application. HA and DR concerns. I assume everybody familiar with HA, high availability, and DR, disaster recovery. So I've sprinkled acronyms in all over the place. If I say something you don't know what that means, please stop me. I'm hoping we'll have time to take a look at a quick, very simplified architecture that kind of helps us understand how one potential way of architecting a large scale application, and then we'll wrap up. I would opine that there's been two, maybe 2.5 significant events in the last 5 years that have really changed cloud computing. I mean, anybody want to offer up an opinion or a guess on what those events would be?
Pandemic.
COVID, right? I mean, I know on our Azure side, that was a huge spike of Microsoft Teams as everybody started going global and or remote, I should say. It really fueled a lot of digital transformation and app modernization. Another one fairly recently. That's right, Gen AI, right? So Gen AI has really changed the way that you have to do computing. I mean, GPUs and the GPU infrastructure and architecture inside of a data center is much different than just traditional CPU memory and disk compute. So it has different requirements, notably power consumption, and you'll kind of get a theme here as we go through this. I would say there's kind of a 2.5 or an honorable mention here. War in Ukraine. In Europe, that put a pretty big damper on power consumption or power availability, how much power our data centers can consume, and things like that. So I'm old. Anybody know what this show is? Go ahead. Facts of life, right? So my little gimmick, facts of life, facts of cloud, right? So some of these may be Azure specific. We get told mixed things from AWS and GCP of whether they're having the same issues. I have customers that tell me yes, they do, or no, they don't. But I'm talking specifically about Azure. One lesson learned over the last 5 years: cloud is not infinite, right? These data centers are huge. They're expensive. They take a long time to build. That when you get into like COVID and then you have building supply issues, you have supply chain issues, Power, right? I mean, power is the big one right now. Being able to ramp or turn on a data center that's going to require megawatts, right? I mean, that doesn't just grow on trees. So all of that has put a crimp on the ability to scale up ungated, right, or undeterred. Um, Second one, shit happens, right? I mean, uh, no matter how much you've architected your applications, there's always something that you didn't see coming. They can happen anywhere. You have a lot of external dependencies on your applications. Twilio, OpenAI, I mean, go down the list. There's a ton of them out there, and they can fail, right? And you really have no idea how their app is architected, so you don't know when they're going to go down. So you have to incorporate all that into your planning and your anticipation of what may go wrong. HANDR, it's expensive, right? Like in my job, I talk to CIOs or directors or VPs, and they all say, my application has to be online, right? No ifs, ands, or buts. And then we architect it and we show them the price tag, and they're like, oh, well, maybe it's not that important. You know, we can figure out how to back off of that a little bit and think of other strategies that we need to go deal with. Point being, there are apps that save babies, keep planes in the air, those kind of things. There's apps that make a lot of money, and every situation's different. And whoever is the responsible party on that side has to develop a practical sense of where they fit in that spectrum because there is trade-offs on cost benefit. Um, Another big one that we're going to talk about today, data residency. That is an increasingly important part of any compute platform, right? More and more governments are stepping in saying, hey, I need my constituents' data to stay in my country. That makes it very hard when you're talking about the hyperscalers like AWS and Azure, where frankly, we can't have data centers at that scale in every single country. So that is becoming a more and more complex issue to deal with. And then the third one, AI is here, right? I mean, I think probably everybody in this room has gotten a grasp of that, that it's here to stay, it's moving very fast. If you're not dealing with it in your day jobs yet, you probably will be soon. But we'll talk more about that. All right, so let's talk about data residency concerns. To understand that, from the Azure standpoint, it's important to understand how we do billing and how you deploy Azure OpenAI pieces inside of the cloud. And I'm assuming, and we're not going to get too far into the actual guts of the AI stuff, but you know, you've got OpenAI, which is a kind of an independent company that Microsoft has invested in, and other people now. And then you've got Microsoft, and generally Microsoft takes those models that OpenAI creates and publishes. We bring them inside of Azure and we host them inside of our mechanism, which adds a bunch of wrappers around safety concerns and enterprise scalability and all those kind of things. So when I talk about AI, GenAI, OpenAI, I'm generally referring to the component of that that's running inside of Azure. So Azure OpenAI, you've basically got two models. You've got the pay-go model, which is, hey, we're going to pump X bajillion tokens through GenAI to generate content or summarize or whatever you're doing with AI. And then we've got this notion of PTUs, provision throughput units. This is like dedicated capacity where you're essentially buying some fractional PTU or GPU. It's abstracted, but that's kind of the idea. And then you're guaranteed to get a certain amount of throughput. And it's more expensive, and you're committing at a month at a time. The reason why it's important to understand those two is you need to architect for that. You know, Microsoft is pretty keen to tell our customers that if you're running production grade Gen AI apps inside of Azure, you probably should be using PTUs. That gives you that predictability and reliability you're looking for. But you also get into this problem of, do I really want to buy PTUs to handle my peak workload? Do I want to buy PTUs to handle my baseline workload? Right? I mean, there's no perfect answer there. You kind of have to do the math to figure out where you want to sit in that scale to save money, get the capacity you need, but still, we kind of call it spillover, spillover from your PTUs into PayGo when you max out your PTU consumption or your availability, right? You'll get throttling 429 errors. And so um, you need to be able to find that sweet spot there. And I got my slides not in the right order, but I'll circle back on that here in a minute. The other aspect is this data residency, right? So this is where we get into this idea of how is AI handling our data? Where do we need to deploy those PTUs and that PayGo capacity in order to be able to architect these applications? If I'm a SaaS provider or an ISV and I have customers around the globe, how do I build these applications so they not only scale out for performance standpoint, but also keep the data where it needs to go? And that's driven by a lot of things. I mean, that's driven by government oversight. It's driven by industry standards and oversight. It can be driven by your own internal corporate governance, right? If you've written into your contracts with your customers that you don't process their data outside of their geo, then you got to operate within those boundaries, right? So when we're talking about Azure OpenAI, there's kind of three different deployment levels that you can choose from. Global means that I'm going to take this Azure OpenAI resource, which is really just an API endpoint for the OpenAI, and I'm going to deploy it. I can still pick a region inside of Azure. So Azure has 60 some regions spread around the globe. Probably, I don't know, 12, 13 of them are in the US. So we'll kind of use that as an example. I can say, hey, I want to put my data, any data that's stored, I want to keep it in South Central US, but I'll let you, OpenAI or Azure OpenAI, process it wherever. So do the inferencing anywhere in the world where there's capacity. For some companies, that's fine, right? I mean, I think Microsoft believes by the letter of the law that meets most compliance needs, but most of the customers I work with, they don't like that, right? I mean, they don't want to have their customer data that lives in South Central US get processed in Dubai or Germany or something like that. So, point being, global capacity. You declare a region where you want any data at rest to remain, but you can process it or inference it anywhere. There's a new concept. This is the second level down called data zones. I think this is the sweet spot, in my own opinion. This is where you basically, or Microsoft has defined geopolitical boundaries like the US and Europe to say, okay, same idea as global. You pick a region you want to store your data in, but we'll only process it within that geopolitical boundary. So right now, there's only two data zones, US and Europe. But I mean, for a lot of companies, that's probably 80, 90, 100% of their workloads. So that is a new mechanism that we're offering that allows a lot more flexibility. And we'll talk about why these flexibilities are required. You'll notice kind of this bottom bullet point in each of the three. From global, we talk about ample TPMs. That's the notion that Microsoft is gating your access to how much data you can pump through generative AI models based on lots of factors, but basically we grant you quota, right, to do that. It's easier to get quota in a global zone. Like we'll give you, I think, 1 million tokens per minute if you're willing to deploy in that global model. If you're using the data zones, it's less. I don't know what it is off the top of my head. Let's call it 500K tokens per minute. That bottom one, standard, is probably the model that most people are kind of associated or familiar with from an Azure standpoint. That is, hey, I've deployed my app in South Central US. Therefore, I want to be calling the GenAI inferencing endpoint that also resides in South Central US. Now, if you're familiar with GenAI, the latency is like 1,000 times more on the inferencing than it is the network traffic. So it doesn't really matter how close your data is to the inferencing necessarily. But it's an old cloud concept that most people tend to rely on. The problem with that is that's where capacity is most constrained, right? That's where we on the Microsoft side have the least amount of flexibility to process your data because we are in that model, the standard model, we are guaranteeing that we're only processing that in that one specific region that you've deployed to or stood up that resource. So it makes it harder to get capacity in those regions. It makes it harder to get model consistency across regions, right? So there's a lot of things that are going into that that kind of work against you. Not every of those 60 some Azure regions, they're not all created equally, right? Everyone's probably has some familiarity with availability zones, how you take an Azure region. AWS does the same thing. You carve that into different physical data centers and you run independent power, connectivity, cooling, and all the parts into those data centers, which means in theory you've kind of guarded against failure. And we'll talk more about that. But I guess the point of this slide, increasing amount of pros and cons as you go down the options. And if you're building an enterprise application, you need to think about this as you go into that. How are you going to deploy this? How are you going to keep your data localized to the regions that you're operating in? How many endpoints does that end up being? A lot of that kind of stuff. Good. And please stop me if you guys have questions or anything. So this is a critical piece of how you build these applications is this notion of an AI gateway. I don't think this is a Microsoft specific concept. There's a lot of focus on this here. The idea is that I'm basically going to take a gateway. I mean, you guys, generally speaking, know what a gateway is, or a proxy, or API management, call it whatever you want. And I'm going to layer that above all of my API endpoints, including perhaps going back to the US example, maybe I stand up some OpenAI resources in South Central, but I do others in West or East, and I can cobble together more capacity if I have that flexibility, right? We talked about the different model versions. So in OpenAI, who drives all this, right? Like they've just the other day, Sam Altman said, okay, we've screwed up. We've created too many models, too much confusion. We're going to back off of that and start consolidating that down, right? But the point for now is that there's all these different models. You've got GPT-4 Turbo, 4.0, 4.01, right? I mean, that's 3 flavors. And then within each one of those, you've got multiple versions, like just typical versions that a customer is going to have to pick and choose from, right? Because if I'm building prompts or an application, I've got to go retest that for every one of those versions. Anyway, back to the AI gateway. It allows me to put that abstraction layer or that proxy layer on top of those API endpoints, which makes it much easier to build out an application. So moral of this story, make sure you use an AI gateway if you're embarking on a generative AI application. That spillover that I mentioned earlier, right? Being able to max out the capacity that you're using on those provisioned PTU endpoints and then spill over to PayGo as I go. So as soon as I start getting 429 errors, I have this built-in retry policy that's going to shift from PTU endpoints to PayGo endpoints. Versions and upgrades, we talked about that. Security rotations and security keys and secret rotations, right? I mean, OpenAI works on API keys for the most part, right? So I have umpteen bajillion API keys out there that I've got to keep associated with their particular endpoint. I want to be able to rotate those and keep everything secure. I have a much easier way of doing that if I build that into my AI gateway layer instead of into every little application that's using those AI endpoints. So if you're familiar with like API management, I can run API management as my AI gateway layer. I can make that OAuth authentication or whatever certificate-based authentication I want. And I can bury all of those secrets and the technical implementation there down below that AI gateway so that my apps never have to worry about that. I also get observability monitoring, chargebacks if I want to charge back my OpenAI usage to the apps or the teams that are building them, or even to my customers that are using features of my application that use AI. Circuit breakers, rate limiting, retries, all the good stuff that I usually get with something like an API management solution. Again, moral of the story, build in an AI gateway into your applications. And we'll talk a little bit about why that matters as we get into this. This is just another slide. Sorry, I should have pulled this up a minute ago. You can kind of see on the right side there, those are all my various AI endpoints, whether they're Azure OpenAI, they're OpenAI, Hugging Face, stuff that's hosted there, Mistral. It doesn't matter, right? I mean, this is not an Azure or Microsoft specific concept. I think pretty much everything else we talked about there. But that's kind of the notion of where an AI gateway fits in. All right, so now let's talk a little bit about the HADR side of things, right? I mean, what are we really guarding against? What is practical? How much am I willing to pay for that? Where are my risks? So for high availability, right? This, in my opinion, is the ability to remain viable when something unexpected happens, whether that's an outage or some sort of a failure. That happens in all flavors, shapes, and forms, right? So power outages, cooling outages, obviously localized network hardware failures happen all the time in the cloud. The goal is that we, on the hyperscaler side, hide that from you with our own internal HA and architecture, but it still happens. I mean, unfortunately, on the Azure side, we've had our fair share of outages in the last year or two. So it happens. You can shoot yourself in the foot, right? Deployment failures, or you deployed bad code, updates, right? I mean, safe deployment methodologies can go awry. So a lot of different things that can happen there. I mentioned this one earlier, you undoubtedly have lots of external dependencies that are out of your control. Third-party outages, I mean, they could be running on-prem in their own data centers. They could be running in a different cloud. So it doesn't necessarily correlate to an outage that you would have in your application. So you've got to have those mechanisms in place, effectively built into your application to allow you to either fail back or use some other resource or transition to another region if their service offers a regional model, all different variety of things that you may run into there. But you do want to be able to as best you can, anticipate those failures and have that architected into your solution. When it's all said and done, this bottom bullet point here, I think this is what everyone guards against when we're talking about HA, right? Are we going to lose money if we go down? And usually the answer is yes. I mean, usually if the answer is no, then people are willing to just let it go offline for temporarily until the data center or the network comes back online or whatever the case may be. But every CIO out there, every CEO out there, CPO, right? I mean, they are all guarding against their app going down and losing money. And so it becomes a pretty simple equation. How much are you willing to pay to make sure you don't lose that money? And that's what I don't think many C-suite people do a good job of, right? They don't have a practical sense of that. They don't really have well, some of them do, but they may not have the metrics defined to understand what does 5 minutes of downtime cost us? What does 5 hours of downtime cost us, right? How much is it going to cost me to make sure that I don't have those 15 minutes of downtime? So there's a big equation there, big but simple, right? Because it all boils down to money. All right, so disaster recovery. So high availability, we're mostly focused on just making sure our app stays online, right? And again, whether that's the AI aspects or the Redis cache or Elastic or whatever it may be. In my mind, disaster recovery is that next layer, right? So something bad has happened. That could be anything from a meteor hitting a data center, earthquakes, fires, ransomware attacks, right? I mean, unfortunately, we see a lot of customers going through that these days. Cyber attacks, right? Natural disaster, we mentioned Ukraine earlier. I mean, a lot of things can happen these days in terms of geopolitical, uh, who knows what can happen with that, right? But the point is that if I lose access to my application or my data, or that data is destroyed or encrypted by some ransomware attack, what do I do then, right? Where's my data been backed up? What applications or how much of my system is redundant in some sort of active-active or active-passive system? What is my pathway to get back online in the event that I don't have the option to just wait around for 15 minutes for power to come back on, right? So that gets a little bit into a different conversation than just the HA. And again, it may be evident at this point, like I don't have all the answers here, right? I mean, this is really just meant to kind of bring these topics to the surface, make sure that, the ones that are, implementing all this on your side have thought about this, have a practical lens on things and work through it. We will talk about a few things here in a minute. Yeah, so this is kind of my simplified architecture, right? The idea here is that if you want to be HA and you want to have disaster recovery and you're using GenAI, like this specific snapshot of an architecture here is very GenAI focused, just because we're talking about some of the data zone usage and those kind of things. But the idea here, I've modeled up two geopolitical regions, United States and Germany. You can see those labels across the top. In the United States, as with most cloud providers, our biggest presence is in the US. So we have a lot of options. On that far left side, we're drawing out West US 2, which is one of our bigger Azure regions. It's got 3 availability zones. So I've got the ability, for example, I don't know how well you guys can see this, but I've got multicolored little squares there. AKS is kind of the presumption there, but name your compute layer or substitute your own compute layer there. But the idea is I'm spreading my compute across 3 availability zones. I'm spreading my data across those availability zones. That's the hardest part, right? I mean, what is my data? Am I, a cloud modern or modern cloud application? We would push customers to something like Cosmos DB, which, if you're familiar, is Microsoft's kind of cloud native database solution. It has flavors of SQL Server. It has flavors of NoSQL. It has Mongo and a few different interfaces that you can put onto it. But the idea is it's multi-region, multi-AZ read-write if you want to. Of course, those things cost money to turn on, but that gives me the ability to use a data backend that can stay resilient across those availability zones or even across multiple regions in the event that something goes wrong. And that's pretty key. As we move on, we'll talk about, let's just pick on the right, or I guess maybe the middle column there, that second region inside the US. Let's say we pick West Central, which is up in Cheyenne. it does not support availability zones. So when I said earlier, not every Azure region is created equally. West Central does not have availability zones. So it's all just one regional configuration. So I can still use that, especially in a multi-region environment where I've got an application that is multi-region, it's spread out over a couple regions. I mean, the likelihood that West Central and all three availability zones in West are going to go down should be pretty low. Knock on wood, hopefully. And if that does happen, there's probably bigger problems in the world than just that. But the idea there is I don't need to have those availability zones there in a multi-region deployment, right? Because I am multi-region. If one AZ goes down, one of the things I try and preach to my customers is it's either up or down, right? That whole vertical stack is either on or off. So as soon as I start having problems in one of those regions or that vertical stack, I just turn it off. I route the rest of my traffic over to the other side or one of the other regions that's up and running, and I stay online. That makes it much easier. The customers that try and get too fancy there, they fail all the time, right? I mean, they hit a disaster or some sort of outage. They try and outsmart themselves, and it just goes bad, and they don't have much success. So think of these as pods or units or whatever. Build your application so that it's either on or off within each region. Or on the left side, you can do that from an availability zone side too, right? So one of the models I see customers doing is, you can create a Kubernetes cluster that's multi-AZ, and it'll spread your compute nodes across the AZs. You can also flip that and create three Kubernetes clusters where all the compute is in one of those zones, right? And so then I'd love to draw on this, but I can't. I could lose zone one there. And if I just keep with that notion that it's either on or off, I turn off zone one and I let zone two and zone three pick up the slack there, along with West Central. So does that make sense? And then the big notion here is that data zone I'm using in the middle for my OpenAI or my GenAI. As I talked back on that other slide about kind of the three tiers, and I said data zone's kind of the sweet spot, at least for the US and for Europe. That gives me the ability that I don't really need to worry so much about regional failures, right? That's already a multi-region service endpoint, right? My API endpoints are multi-region. So I don't have to rack my brain about that. I don't have to get overly complex with my deployment models. I'm good to go. It also makes life a lot simpler from managing capacity and quota and access to these different models. And of course, I've got my green squares, which are my AI gateways. They're abstracting everything that's actually hitting the GenAI endpoints. Good with that. So now let's talk about Germany, right? So Germany's inside of Azure. Germany has some repercussions from the Ukraine war, power related, and some other stuff. But let's just assume, and this is partially true, that Germany only has one region, right, inside of Azure. It does have availability zones, but it does not have all the models for my GenAI, right? So I don't have that luxury of creating that spillover effect completely within Germany, right? And depending on what your data governance requirements are and everything else, that can be, not a big deal, or it may be a huge deal. But the idea there is that I can use that, again, back to that slide, my lowest rung, I can pick my standard deployment model for my AI, use that as much as I can. And if I need to spill over for some reason or fail over, if that service would go down, I can spill over into the Europe data zone region, right? And again, like I said, that may or may not be feasible from your data governance requirements, but it's semi-practical, right? And all of this to say, if you're a large enterprise customer, or you're building an app, or your customers are in multiple regions, the more multi-region you can get at a practical cost, the more insulated you'll be from any kind of localized failures. The last thing I would call out is more on the disaster recovery side, right? So ship your data outside. Obviously, you want to get it outside of a specific Azure region or a specific geo. I think you should get it out of Azure or even the cloud altogether, right? So if you're worried about the worst things happening, you have to be considering things like what would happen if Azure just went dark for days, weeks, months, and you had no control over that, right? So get your data out. You probably still have to keep it in region, wherever your data governance requirements are, but you can put it, I mean, wherever it's safe and locked away, and shift it from Azure to AWS or vice versa, but guard against that. All of that is way easier said than done, right? So this is very oversimplified. I think to kind of, well, we don't have time to get into that. To get into kind of the end summary here, HADR, expensive, hard, not very many customers are good at it, just to be frank, right? I mean, they always run into problems. If there is an issue, they're caught for some unforeseen reason why they can't fail over from one region to another. So you have to be practical and realistic. You have to try it. You have to work on it. Doing a fire drill once a year is not sufficient. Like, you need to be failing back and forth monthly, daily, weekly, whatever the case may be, just to make sure you iron out all of your procedures and your pipelines and everything else. Another big lesson that I think everybody's learning these days, security and cyber are super important, right? I mean, I work with some customers that have been taken offline for a month. I mean, talk about losing money and downtime, and not to mention the PR and the news that comes with that. You want to be avoiding that. So consider that into your plans for HA and DR. Speaking from the Azure standpoint, for better or worse, capacity and quota are here to stay, right? I mean, the idea that compute is infinite and that you can just flip a switch and have 5,000 cores of SQL Server up and running are not practical anymore. Regional failover is not guaranteed. That is, let's say you have an active passive system, and one of the Azure regions goes down, and you think you're going to just fail over to another region, run some pipelines, stand up some infrastructure, and you'll be good to go. Well, so are 50,000 other customers doing that at the same time. And for better or worse, Azure does not operate at a scale where we have 50% spare capacity that we can just collapse two regions into one. So be prepared for that. Be flexible in your pipelines and your infrastructure as code so that you can deal with that. And then things may be out of your control, right? You got to anticipate as much of the unanticipatable as you can. Build your applications in a way that they're resilient. Again, easier said than done, but hopefully this has given you a little bit to think about. This isn't the sexiest topic of the day, I'm sure, especially when we're talking about all the cool stuff you can do with GenAI. But these are the things that the customers I work with are starting to go through as they really build out these enterprise scale AI applications.